Hi everyone, in this tutorial video I would like to share with you about PLC ladder diagram solution for an industrial application. For this time, this is 4-tank system which incorporate with several sensors. So have a look. So we have 4 tanks. This is tank number 1, this is tank number 2, this is tank 3 and tank 4. On the switchboard we have start push button. So this one is start push button. Start push button. We have stop push button, and this one is valve push button. On the tank itself we have pump 1. This is pump 1, pump 2, pump 3 and pump 4. We also have valve 1, valve 2, slightly hidden behind this bar is valve 3, and this one is valve 4. Okay. The operation for this particular example, just to make it a little bit interesting, when we press the start push button, which is this one, we're going to activate the internal bit register M0.0, and if we press stop push button, we will deactivate the internal bit register M0.0. So here we have the internal bit register M0.0, and this M0.0, the internal bit register, will turn on pump 1. Okay, will turn on this pump 1. So pump 1 will fill the liquid inside this tank 1 until it reach this level. Okay, this one is the level sensor, liquid level sensor, what we call as the, here it is named as H2 tank 1. Okay, so when pump 1 turns on, it will fill the water, the filling process, fill the liquid inside this tank until it reach level H2 somewhere here, and pump 1 will stop. Okay, pump 1 will stop. At the same time, M0.0 will turn on timer 0, and timer 0, assuming that the timer 0 is SODT, timer 0 is SODT, on delay timer, and on this on delay timer will timing for the preset value for on delay timer is 10 seconds. It will run for 10 seconds. After finish 10 seconds, pump 2 will turn on. Okay. So pump 2 will turn on after finish 10 seconds until it reach H2 tank 2. Then pump 2 will stop. Okay. So next is for pump 3. The activation is for pump 3. Again, depends on the activation of start button, but the start button must be pressed twice. Okay, so bear in mind that we already pressed the start button earlier to activate M0.0, which then resulting the opening of P1, pump 1. That is the first activation, and then we press twice, means we press second time, and we press third time, means start button is pressed 3 times so that P3 will operate. So P3 is depending on 3 times start push button activation. And looking at this particular description, we know that we need to use counter. So my advice in this particular tutorial, we're going to use counter down instruction for activation of pump 3, and again pump 3 will stop at this particular level. I name it as H2 tank 3, and finally we have pump 4, and pump 4 will activate depending on the start button, but this time the start button must be 4 times. So this one, 4 times start push button activation. Then after 4 times start button activation, pump 4 will turn on, then fill in the liquid inside the tank until it reach at the middle point, the middle position, based on H2 tank 4. So now assume that all 4 tanks have liquid. Okay, all 4 tanks have liquid. Now the next process is we're going to drain the liquid from these tanks, tank 1, tank 2, tank 3, and tank 4. So in order to drain the liquid from the tank, we have to activate the valve push button. And to make it more interesting, the valve push button activation is based on negative H detection. Okay, detection, meaning to say we have to press the valve push button, nothing happened, but as soon as we release it, then the negative H detection will detect the release activity, and all the valve will turn on and drain the liquid from the tank. Okay, and the valve will turn off, mean the valve will close if we press the stop push button. Okay, if we press stop push button, and we're going to solve this particular problem using SIMATIC Step 7. Okay, first we have to prepare the symbol list. So we have the start push button as the I0.0 as the input. Then we have valve push button I0.1. We also have the stop push button 0.2, input 0.2. We have the H2 tank 1. This is basically the sensor which detect the liquid level in tank 1. H2, just put the name H2, means the liquid level is in the middle position. Then we have for liquid level for tank 2, H2 2. We have H2 tank 3 for tank 3. Then we have H2 tank 4. Okay. We also have the low level sensor, low level liquid sensor, low tank 1, low tank 2, low tank 3, and low tank 4. Okay. In terms of output, we have pump 1, this is Q0.0, and we have pump 2, Q0.1, pump 3, Q0.2, pump 4, Q0.3. In terms of the draining valve, we have valve 1, Q0.4, valve 2 Q0.5, valve 3 Q0.6, and valve 4 Q0.7. Okay, I think that's all for the input and output. Then we're going to use this particular input and output with the address assignment with for the ladder diagram construction. Okay, we're going to construct the ladder diagram using SIMATIC STEP7 software. So for network 1, we're going to design the ladder diagram for the start push button. Start push button will activate M0.0. At the same time, if the stop push button activate, deactivate. If stop push button is pressed, it will deactivate M0.0. Okay, we're going to use this one is start push button. Start push button. Then we can use the SR instruction. So SR instruction, this is stop push button. Okay, start push button will activate M0.0. Okay, just put another internal bit address here. Start push button, when start push button is activated, it will toggle M0.0 and M0.1. And because we are using SR flip-flop instruction, it is basically what we call as a dominant stop. When stop is pressed, it will reset M0.0 and M0.1. Okay, as I mentioned earlier, this particular bit, internal bit M0.0, will turn on PAM1. So we add another network, which is M0.0 will turn on PAM1, provided that the PAM1 is not reaching the desired level. So in this case, we put as H2 tank 1 as the level required. So this one is H1. We want a H2 tank 1. Yes, H2 tank 1. Okay, so M0.0 will turn on pump 1 as soon as the liquid level in tank 1 reach H2 level, will stop pump 1. And at the same time, we're going to start M0.0 will start the timer 0. So M0.0 will start timer 0. Okay. For 10 seconds. It will be reset by stop push button. Okay. Stop push button, and when T0 finish timing, it will start pump 2. Okay, pump 2. So we will start pump 2. Okay, we will start pump 2. When T0 finish timing, it will start pump 2, and pump 2 will stop when it reach level H2 for tank 2. Okay. Okay. So now we managed to create a ladder diagram or the logic for pump 1 and pump 2. Okay, recall the logic for pump 3. Pump 3 is depending on the number of start button press. If start button press 3 times, then pump 3 will operate. So it's basically a counter. So we're gonna use counter down. So name it as counter down 0. Counter down is this is the sensor. I mean for the start button. So this one is start is set by M0.0, and the preset value is we make it 3 times, I guess. Yes, 3 times. We set by stop button. Okay, and network 5, network 6. Network 6 is basically for pump 3. Pump 3, when this counter finish counting, means this if this counter finished counting for 3 times, it will turn on pump 3. So we have to use, because this is counting down, so we have to use the normally close C0. And in order to prevent pump 3 to start immediately, so we have to use the normally open. This one we can use M0.0, which is related to the network 1. Okay, so if press start button, M0.0 energize, then pump 3 will able to operate depending on counter down, okay? Counter down instruction. And of course pump 3 will stop when it reach level H2 for tank 3. Okay, next is for pump 4. Again, pump 4 we're going to use a counter. Going to use again a counter because we have to activate the start button 4 times. So we name it as a counter 1. This one is start button. The preset value is CH4 to indicate 4 time activation of start button. Set is M0.0. The reset is stop button. Okay, and we have to create another network for pump 4. For pump number 4, and of course pump 4 is depending on nomenclature of C1, and of course we're going to also implement interlocking with the M0.0. So this one we can use M0.0, and of course pump 4 will stop when it reach the middle level of tank 4. This is H2 tank 4. Okay, and finally we're going to incorporate the valve button. So the valve button is the negative edge detection. So we're going to use the negative edge detection. This particular question mark, we have to put the sensor, or basically the valve push button. The valve push button will set the valve. Okay, bear in mind we have 4 valves for individual tanks, so we have to create for individual tank. Okay. Finally, for tank 4. Okay. And this M bit, we just put any dummy bit. Okay. In this case, I'm using M0.2. So looking back, we have start push button. Start push button will energize M0.0, and when M0.0 energize, it will start pump 1. Okay, bear in mind, network number 9, we have all 4 valve is set. We have to reset the valve. So in order to reset the valve, to make it simple, we just press stop push button, then the valve is reset. So we can add a network after network 1. So we just incorporate the stop push button. Okay, stop push button will reset all the valves. So valve 1, valve 2, valve 3, and valve 4. Okay, so we already incorporate the stop button to reset all the valve. Okay, what else? Let me check. So this one, stop, deactivate all valves. This one, pump will stop when at H2 tank 1, and also pump 1 will stop if valve 1 is operate. So this is basically a basic interlock. When pump is operate, valve is not operate. When valve is operate, when valve is set, pump will reset. Okay, the vice versa. Okay, so this one is basically pump 1 operation. Pump 1 operation. This one is timer 0 operation, and then we have timer 0 coil. When timer 0 finish timing, it will turn on pump 2. We're going to use the interlocking of valve 2 for pump 2. So this one is the valve number 2. Okay, when valve is operate, pump is off. When pump is on, valve is off. Okay, but this one is the start button. Press 3 times, it will turn on pump 3. So this one again, we have to incorporate valve 3, and this one is for pump 4. Yes, pump 4. So when C1 finish counting, it will activate pump 4. Again, we have to incorporate valve number 4, the interlocking between the interlocking relationship between valve number 4 and pump 4, and we have finally this negative edge detection. Just save it. Okay, we're going to simulate using the factory I/O. Okay, this is the simulation for all 4 tanks with the switching board, start, stop push button, and also the valve push button. So we're going to start to operate. Look at the network number 1. When we press start push button, we are expecting the pump for tank 1 will start to operate. And after 10 seconds, tank number 2, pump 2 will start the filling operation. I'm pressing the start button, so pump 1 is turning on. This one is pump 1. pump 1 is turned on, and timer is running. Then pump 2 will turn on, and tank 1 will stop immediately when it reach H2 level. Same goes to tank 2. When it reach H2 tank 2, it will stop. Okay, pump 2 will stop because of this H2 tank 2. Okay, so and then we look at the tank number 3 and pump number 3. And for network 7, the pump number 3 is depending on the coil of counter 0. So now the counter 0, we already press start button once. Okay, the preset value is 3. We already press 1, so 3 becoming 2. The current value is 2. So we press another 1 time. From this 2, it will reduce 1 minus 1. Pressing, so it become 1. So, and then I press another 1, the start button 1. When it becomes 0, this coil will become green and pump 3 will start to operate. So I'm pressing the start button. Okay, so pump 3 will start to operate the filling process for tank 3, and it will stop at the H2 tank 3 level, which is this one. So H2 tank 3 will terminate pump 3. Okay, H2 tank 3 will terminate pump 3. Next is for tank 4. So we already press start button 3 times, and the preset value for pump 4 is 4 times. 4 times. So the preset value is 4. We already pressed 3 times. So we have to press 1 more time to turn on pump 4. So that when we press 1 more time, the coil of counter 1 will energize. So this one will become green. So I'm pressing, then this one is energized. The pump 4 is energized, and the filling operation of tank 4. So finally, we're going to look at network 10. We are expecting that when we press the valve push button, this valve push button, it will drain all the liquid from all tanks. Okay, and we already declared the interlocking between valves and pumps. So when valve is set, pump must turn off. All pump must be turned off. So then we press. I'm pressing the valve push button. So observe, because we are using negative edge detection. So I'm pressing. So it will detect the negative edge. So I'm pressing and holding, nothing happened. So you can observe on the network 10, the valve PB is 1, the status is 1, means I'm still pressing, and the M0.2 is 1, meaning to say, in the other word, that I'm still pressing. And as soon as I release the valve push button, all the valve 1 will set, valve 2 will set, valve 3 will set, and valve 4 will also set. Okay. I'm releasing the valve push button, so everything is set because of the valve push button status became 0. So now the liquid is discharged or draining from all the tanks. Okay, so next procedure is basically network 2. When we press stop push button, this one, when we press stop push button, we're going to reset all the valve, meaning to say we have to close all the valve. Currently the valve is open. Okay, the valve is set means the valve is open, so we need to close the valve. So now, in order to close the valve, we have to press stop. I can press stop here, so the valve is closed. Okay, when the valve is closed, here the valve is already closed, so then I can press start again to turn on pump 1. press start again to turn on pump 1, or I can press triple time. I can press triple to immediately turn on pump 1, after 10 seconds pump 2, and then pump 3, or I can straight away press 4 times to turn on according to the sequence. Okay, let me press start button 4 times. 1, 2, 3, 4. See? So pump 2 will turn on after 10 seconds. Okay, I think I hope that the solution might give you better idea about the operation of timer and counter, especially the on delay timer and counter down. So if you have any question, you can just ask me at the comment section. Thank you very much.